Welcome back. This is the hand lecture. And where we're going to start is with a quick review of the landmarks and the bones of the hand, just so that we're all on the same sheet of music going forward. Okay, so we came down to the end of the radius and the end of the ulna, and these create a nice little planar surface at their apex or their distal end. And what slots in there is what we call the carpals, right? So a collection of little bones, almost like a little piece of chewing gum or little pebbles, sit in there. The names aren't really important to us. I'm not going to mention any of these by name in the lecture, with save one. I'll talk about one little guy at the base of the pinky side of the hand called the pisiform, but that's the only one. And if we switch views over to this side, you can see the pisiform is this little protrusion. And it's kind of an accessory carpal, actually. It's not one of the main carpals. And this really is important because it's the insertion point of the flexor carpi ulnaris. Right, so that's coming into the very base here. And you can quickly and easily find it on your own body, just at the big kind of prominent bone projecting on the pinky side, right down at the base. Okay, so that's one to know about the carpals. The carpals themselves distribute rotation throughout the wrist in a very complex way. It's not simply broken down into a single point of rotation. And to get into too much complexity is beyond the scope of this lecture, because we're primarily concerned with form and not necessarily all the kinematics of it. But suffice it to say that the rotation point is distributed between rows. So if you're flexing the hand forward, you have rotation points at the base here, and also rotation points through between rows of carpals. Twisting happens somewhere in here, between pronation, supination between the radius and the ulna. And side to side happens as a big kind of distributed rotation, where the carpals actually slide against their mating surface on the distal ends of the radius and ulna. So that's it. That's all I'm going to say about it. We have bigger fish to fry as regards to sculpture. Okay, so just consider this a nice transition mass that takes us from the end of the radius and the ulna into what are called the metacarpals, right? So meta being beyond or further from beyond the carpals, right? Metacarpals. Okay, and obviously there's one for each finger. First finger being the thumb, last being the pinky. And what we have is kind of a nice consistent projections coming off the back for the second to fourth, what we consider the main fingers. And actually the thumb's metacarpal is the exception to this little design pattern, in that, in the same way the thumb is an exception, this joint is highly mobile, right? So this is a saddle joint. So we have all sorts of degrees of freedom here. We have not just flexion and extension, but we have also abduction and adduction. So in this is going to look like the exact same arrow, but in a different plane. You're pulling the hand, the thumb in or away from the hand, and this is rotating it into the palm. And if these are confusing, it's because they're actually very similar actions. And when we get to the muscle review for the thumb, we'll see that the muscles that adduct and pull it in and flex it are almost exactly the same in location. They're just side by side. A little difference in their origin gives you the difference between flexion and adduction. Okay, so that has a lot of mobility. So we'll look at this angle. So this will be changeable. The next metacarpals are mostly fixed. Well, the first, the second, and third. When we get to the fourth and the fifth, we actually have a lot of mobility as well in these two. A little bit in the fourth, massive flexibility in the fifth. And this is what kind of gives you the ability to touch your thumb to your pinky is the ability of this metacarpal to bend, in addition to the rotations at these further joints. Just feel it for yourself right now. Just move your pinky in and out and look down the axis of your hand and see how much you can move this joint about this rotation point. Okay, and you'll see in the working example this week I pose my own hand in a way that actually rotates this, and you may do the same. But just be aware we have rotation there and the possibility of rotation here, and massive 2-axis rotation at the base of the thumb's metacarpal. Okay, from there, past the metacarpals, we have digits called phalanges, right? Collectively, these are the little bony digits of the finger. Individually, phalanges is plural, singular is phalanx, so any one of these is a phalanx. Technically, you're talking about proximal phalanx, nearest the metacarpals, mid or middle phalanx, and distal phalanx for the very tips. And likewise on the thumb, it's just proximal and distal because there's only 2. So that's the other thing about the thumb, is there's only two phalanges, right? Okay, not a surprise. That should all be review. We'll get to the proportions of these bones in a couple slides, and that's critical for our operation today, and operation as a sculptor of hands in general, is to really be able to get the proportions correct. Okay. On the front of the palm, it looks pretty much the same as the back of the palm, to be honest. If we actually had muscles in here, we'd start to see some of these anterior masses start to form. And I'm not going to draw all this in. We have slides further on for this. But this whole little section on bones just gives me a chance to emphasize the point that when we're doing hands, you really want to distinguish between what is bone and what is fleshy. Like, that is all the critical things. That's one of the critical aspects to achieving success, because the bony sections are angular and always have strong, hard planes. The fleshy sections, like as you rotate around the thumb, for example, are round and bulbous. And when you hit a certain angle, you see a transition from round to hard, right? And it's being aware of where these transitions take place, both orbiting around the palm, and so these masses in the palm, but also around individual digits. You know, where does the fatty pad, fleshy kind of skin fat pad that covers the fingers, where does it kind of end and attenuate and turn into the hard back of the hand when you rotate around a finger? These are things that you guys need to look for and understand. Okay, muscles. I'm not going to cover too much about the individual muscles. I'll cover them quickly, but the big thing I want you guys to understand is the masses that are created by them. And anatomically, they're called the thenar mass, which is the thumb side mass, which is this big collection of muscles, and on the opposite side you have the hypothenar mass, right? And those are the 2 big masses there. And those are composed of individual muscles, which, like I said, abduct here and flex here. And then this right here, so abduct is to pull away, flex is to pull the digit in, and then this right in this pocket here is an adductor, meaning it pulls the hand in. Okay, and then we have a little muscle in here called the opposition muscle, and essentially this is one that helps you to use the thumb in opposition. Touch your thumb to your pinky, touch your thumb to your 4th finger, 3rd finger, 1st finger, or 2nd finger. You get the idea. So all these things just have a very slight difference in origin, meaning somewhere further along this carpal ligament, and just a slightly different direction of pull results in a hugely different action. Okay, so remember these masses. The actual muscles are somewhat less important. I will talk about kind of abduction and flexor a little bit in my lecture or in my working example, just because you can sometimes see a distinction between this mass and this mass, but not always, right? In general, we can treat it as a single mass. Now, moving into this nice little pocket in the between the thumb and the second finger, right? The index finger. We have this little kind of bulge that we're all familiar with. It sits in that little angle, and you can pop it out by pulling your thumb and touching your first finger this way. And the name of it is called the first dorsal interosseous muscle. And really, it actually doesn't have anything to do with, well, it's kind of a combination action of pulling the thumb in, but also rotating your finger to the side. Pretty much it attaches at the base of the first phalanx, the proximal phalanx of the index finger, and it pulls down into the pocket. So it pulls your index finger towards the thumb, right? And you can get your first dorsal interosseous to kind of pop out by wagging your finger back and forth, right? And this really creates a little egg shape in here, depending on what the thumb is doing. So look out for it. And it's a really nice little shape, and it fits in between the angles of bone established by these metacarpals, right? So in the previous slide, I talked about really finding and knowing what areas are hard and what are soft. All of this here is hard, soft in the middle. And likewise, just on the other side of this is those the thenar mass that I was just mentioning. So again, soft. And it's being able to put these in the right place that's really important. Okay, let's just look a little bit forward. This is Bridgman's hands, right? And part of your assignment for this week, which you'll see, is to do some reading, and I have PDFs from Bridgman and also from Loomis. Okay, and they're just really kind of powerful schematic representations of these two masses we're talking about. The hypothenar mass here, and then the thenar mass over on this side, right? And how it comes and locks around onto the side of the thumb. And this pisiform right in here, and this is the head of the ulna, right? And then you have some tendons coming down here. Okay, Bridgman does a fantastic job kind of drawing the very hardness of the knuckles, and almost too much so. You won't ever see anybody's hand that has this kind of thing in it, but he's quite expressive and quite good for learning from. You know, you can really make out that this is bone and hard, like I've been mentioning, and that this is the soft mass, right? That is the secret, finding and being able to describe these transitions. Then over on this side is the first dorsal interosseous. Okay, first dorsal interosseous. And then this is the side of the thenar mass. Okay, and then, like I said, shooting right down there, bone, but also tendon, right? The thumb has a bunch of magic tendons that come into it. And we saw these thumb muscles when we were doing the forearms, right? These were sitting right at the end of the radius down here. And actually, there's another one that's sneaky and hiding underneath the extensor digitorum. So let me just describe these really quick. You see them here. So attaching to the thumb at the kind of the phalanges, you have two extensors, an extensor pollicis longus and an extensor pollicis brevis, pollicis being the thumb, right? Kind of anatomical speak for thumb. Longus is going here, underneath over to the ulna. It kind of attaches on the ridge out here. And the extensor pollicis brevis is this one, number 2 here. And this is coming in. This is the one that we know kind of slots under extensor digitorum. Okay? And then finally, we have this one, which is labeled 1 here. And this is kind of the longer of the longer of the three, longest of the three. and this is something called the abductor pollicis longus, right? And it actually comes in and inserts at the base down here of the first metacarpal, right? So it doesn't go down to the thumb, but attaches there, pulls the thumb away from the hand, right? It abducts it. So those three. And you'll see in the sculpt that I do this week, and you can see it actually on yourself right now, this little triangle in between the two tendons when the thumb is flexed back, extended back. This is called the anatomical snuff box of the body, because apparently people used to put snuff in there and sniff it out of that little pocket in between your extensor tendons of the thumb, and what ends up being the hard end of the radius down here kind of ends the anatomical snuff box. Okay, I hope this is somewhat clear. This is, if you're not oriented, I'm sure you are by now, but the thenar mass of the thumb, first dorsal interosseous, and first finger going out here, or the index finger, technically the second digit. Okay, so those are the tendons to keep an eye out for. Likewise, going down the back of the hand, we have extensor digitorum coming down, distributing tendons to kind of the first three, and then a tiny slip to the pinky that branches off, but also pinky, remember, gets the tendon of extensor digiti minimi coming down as well, so it gets a little bit of special treatment going down this way. Okay, and all these are coming up to the forearms muscles that we looked at this week. So again, keep an eye out for these. Depending on what pose you'd end up doing for your assignment, these will pop out as well, but only to a certain extent. They're not going to pop out all the way down to the forearm, because there's a little plaster that sits over the back of the hand here called the extensor retinaculum. It's a little kind of almost like a piece of tape that's lashing all these tendons down against the wrist, right? And that means that you're only ever going to see this much of the tendon popping up. Okay, quick review of that stuff. Now let's get to distribution of digits and kind of location of these fat pads. And pretty much the first thing I want you guys to appreciate as we start to look at the fingers is that on the back, your rotation point of the knuckle is exposed, right? So these would be your hard knuckles on the back, right? Assume this is a dorsal view, right, looking down at the top of the hand. Those would be your knuckles. If you punch somebody, this is what you would hit them with. Okay, and so the end of the fingers are out here. When we talk about proportions, we're going to talk about distributing these lengths and putting your intermediate rotation points in here, which correspond to these little funny looking things at the back of your hand. And we'll talk about this from the back view. And roughly, to give you a preview, it's take the length of the finger from tip to base, tip to knuckle, divide it in half. So this is 1/2, and this is 1/2, and that's your next joint. Take this distance from that joint to the end and divide it into thirds, right? So 1/3, 2/3, and at the 2/3 mark is where you get your next joint. So this is 2/3, and this is 1/3 here. Okay, that's all fine for the back of the fingers, but on the front of the fingers, essentially you have a bunch of pads. So this is half, and this is the 2/3, and this is the 1/3, right? But on the front, because of the way the finger rotates, from the front view, all these digits look to be equal in length, right? And these fat pads cover, well, at least you have the main fat pad covering here, and essentially your fingers are shorter in the front because the palm, the fat pads over the knuckles, comes up here, right? This is the rotation point that we just saw back here, but covered by your fat pads in the front, okay? A complicated way of saying the hand is different on the back than the front, but I trust the hand more on the back. Okay, a slightly more clarifying slide perhaps. This one is from Loomis, also in your assignment. So what we have here is his proportions are from kind of the base of the wrist at the carpals to I suppose it's just beyond the rotation point of the third metacarpal to the end. That's half and half, and then within this we divide in the thirds that we're just talking, half and then third. Okay. I'll just see what else is interesting on this slide. This is in your reading, so you can look at this and kind of understand it. In there, it talks about the rotation point of the thumb, kind of the radius carved out by the thumb as it kind of adducts into the palm. This is what I was just talking about. So his measure is the same as mine. Length of the finger, divide in half for the first knuckle, and then divide into thirds for this one. Right, and then at the base, because of the different distribution, all these are equal length segments here. Okay, I'll let you guys explore this on your own. Okay, the last thing I want to mention about this slide is just to really look at how Loomis describes the planes, because this is going to be really important, and this is kind of critical to sculpture, right? I know he's just doing drawings, but everything that you can understand by executing drawings of the hand translate almost directly into sculpting, because all of these things just end up being contours that we have to describe when our model is rotated into a certain view. You know, all these angles, and a drawing of a hand is so full of information about plane change, about hard and soft, you know, soft down here, hard on the top. He's gone into a bit of kind of construction here, just really delineating the planes. So really, drawing is invaluable for helping to understand hands. So if you're struggling with your hand sculptures, I kind of encourage you to get back to first principles and really look at your hand and draw it. It can be your hand, it can be clippings out of newspapers or magazines, anything. It's just that there's so much information to be learned about the proportions and just the functionality of the hand by drawing. Here are just a couple of the page out of my sketchbook of some hand studies that I do, because whenever I'm working on a hand sculpture, you know, I really just kind of refresh myself on all these things first, you know, really get in about, you know, just look at flows of tendons, you know, try to just understand again about distribution of joints, attachments of tendons down here. We talked about first dorsal interosseous, all these things, you know. So drawing really just it pays off, and it contributes. It's not wasted time because it contributes almost immediately to your sculpture. So if you're kind of looking at this, you know, just look at these kind of subtle contours. All that is something that I would have to capture in a sculpture, right? So it's just good to help memorize and help to understand, see how, you know, understand whether this is the right proportion or not, because it's that vision that's going to make you able to see and correct things in your sculpture as you proceed. So draw is the point of this. Okay, but we're in a sculpting class, so let's get sculpting. We have some hands to do this week. And check out the assignment video for exactly what we're going to be doing, but I'm going to provide you guys with a base mesh, and then you guys can actually pose it any way you want. You're going to be using your own hands as your model this week, and so you can be as crazy or as simple as you want to get a good result. and I walk through this little example, building this guy up from the base mesh provided. And there's a few other how-tos, short tools and technique videos, including making Z-sphere hands, which is kind of interesting and can also give really good results. So get to it, and I hope you guys have a good result. But most of all, take the time, don't rush, and really just observe and try to understand what you're sculpting, because that's the whole point of these exercises, is to study, right? These aren't a rush. I want you guys to just really try to absorb what you're studying and what you're looking at. Explore the forums, try to understand them. It may be possibly better this week for you because it's quite immediate having your own hand in front of you as your reference. You know, it's perfect. It's the best reference. Loomis talks about this all the time. He says, you know, there's only so much you can say. Hands are sitting right in front of you. Go draw them. Right, so that's what I'm saying. Go sculpt your hands, and we'll see how you do next week. Thank you.